Exactly. Domain is X. I love it.
Okay, I see where I went wrong.
I love it. Right, and that little dude walking along the axis. I don't know if that helps that, but you don't even have to do that. You say, what's the lowest output? What's the highest output? That's the range. What's the lowest input I could use? Here I could use anywhere down to negative infinity, up to infinity. That's why it's all real numbers. I can use anything I want to.
Little dude's walking along. He's like, oh, I found it.
Like driving range. Driving range, you hit the ball forward, so you can always think of it like...
Whatever works. Whatever works. Me, that wouldn't really work too well. All right, guys. Any other questions yet?
What is it again? What is it, 110?
That's the.
150 minus 40.
Yes, what is it?
It's the difference in wattage between those
You're
two.
right, you're right.
110 watts, yeah. If you want to see it.
Oh, boy.
Cool.
Watson.
Yeah.
Section 3.5, number 36. I did the table, but I'm not getting that.
Yeah, that's one like the parabola where you got to be careful. You got to find that turning point. So y equal absolute value of x plus 2. So again, you try some negatives, you try 0, you try some positives, right? And thank God later in math you find ways of not having to just guess at what to try. You can actually look at the function and say, oh, I know I've got to go around these numbers, right? But for us, the function should be some negatives, 0, some positives. We should see what we need to see.
When dealing with absolute values, is it negative even necessary?
Now, I want you to realize, I know where you're coming from, but to graph it, I have to see the negatives. Because what does an absolute value do to a positive number?
It's
Nothing. What's an absolute value do to a negative number?
It makes it positive.
So don't I have to see those points so I know where it goes? I can't just do the positives because it's not going to tell me. It's going to act differently with the negatives, isn't it? So I've got to see the negatives, right? So if I only did these, what's absolute value 0 plus 2?
2.
Absolute value 1 plus 2?
3.
3. Absolute value 1's 1 plus 2? 2 plus 2? 4. If I just did these, it would look like that. I would think it's a straight line, right?
But all that's in it is an x, so it's not like, unless x equals
0, 2, 1, 3, and 2, 4. I might think just to make this, right? I might think, if you connect them, doesn't it make a nice straight line?
Yeah.
But you're guessing about what it does back here. You need to see what it does back here. What does it do back there? What's the absolute value negative 1 plus 2?
3.
Careful. I'm sorry. Here. What's the absolute value negative 2 plus 2?
4.
4.
Oh,
So here it goes to 3 again.
X, yeah.
See, now there's the turn.
Okay.
You couldn't see that unless you plugged negatives in. So I know what you're thinking. You're thinking, well, why, absolute value makes everything positive. That's why I've got to see negatives, because it's going to treat them differently. I've got to see what it does, right? So that's the turn there, the V shape. If I could draw a straight line.
So also all real numbers, domain.
Yeah, so this would be almost exactly like that. Right?
Yeah.
Even though there's a V, domain is all real numbers. I can take the absolute value of anything I want to. The range starts at,
Greater than 2.
yeah, it starts at 2 and goes forever.
Infinity.
So you can say 2 to infinity or y greater or equal to 2. Right? Real quick example when it has a problem with the domain, since both of those had like all real numbers for the domain. If I had a function like this, can somebody tell me what is definitely not in the domain?
The fraction, yeah. I was going to say a fraction, but no.
0 is fine. 0 minus 1 is negative 1. 1 over negative 1 is negative 1. What's the only number I can't divide by?
Negative 1.
What's the only number I can't divide by?
0.
0. That's the thing. But what makes the bottom 0?
1.
If x is 1.
Yeah.
So am I allowed to use an input of 1?
No. That's
No,
the
because it would
restriction.
freak this out. You guys see? Domain is all the inputs you're allowed to use. I'm not allowed to use 1. So it'd be all reals except,
Minus.
what do you need to see there? 1. Or you can say negative infinity up to 1. 1 to infinity. So you skip 1. From negative infinity, you stop at 1, start over again, so effectively I skip 1, right? I'll actually take either, I don't care, either way it's fine. Because I just want to show you an example where the domain has a problem. Because normally it's the range that has a problem. But here the domain has a problem. It can't have one. Okay.
Question. One's the restriction then?
Good. One is the restriction.
Right.
So this has a restricted domain. There is an X that will freak this guy out. And that is 1. So I can't use 1. Good. Is there any X that will freak this guy out? No, I can take the X value whenever I want to.
Because if you use 1, it will be 0. and
It'll be undefined.
undefined.
So do you usually find that only in fractions?
Huh?
Do you usually only find the limit domain in fractions?
Well, fractions and square roots. Why square roots? What can I not put in there?
Negative.
I can't put in there. So this has got to be greater than or equal to 0.
No, it's not behind.
Right, so those are your two biggies. Fraction looking deals could have a restricted domain. Radicals could have a restricted domain. That's in our future though. We haven't gotten there yet. All right, so
It doesn't say that.
we are going to get into chapter 4 today.
4.
4.
Do your Boston accent.
So happy.
Chapter 4. That's your native. That's your native town.
Not really, no, it's not.
I guess.
I've been there once.
I guess because of the basketball team. It's like, oh, all right.
Oh, yeah. So when I say the word systems of equations, what do you guys think? You guys think, oh, okay, so one reaction was sleepy time.
No, I was.
Like, what was that?
Systems of equations, pretty much working out a problem.
Okay, okay.
Two lines.
But that's what we've been doing, right?
Yeah.
What's the difference now? What's it mean, a system of equations? So,
Graphing.
2 or more,
2 or more, please.
right? And we will go up to 3. You could go up to 18 billion equations. Oh my God, we won't do that.
Graphing comes to mind.
Good. That's the first method we'll talk about how to solve this.
So chapter 4.
Systems of equations. Oh yes. Substitution, elimination method. that
And this
might
is
come
chapter 4, you said?
from- Chapter 4.
Okay.
4.1.
So let me give us an example here.
Section 1, right?
Yeah.
Professor, section 1?
Yes.
Okay, good.
Systems.
All right, this is a very easy example to start off with. But I really want you guys to understand the idea here. How many answers are there to number 1 by itself?
Because you have an X and Y, so you
How
can
many
have 2
answers
answers.
does this have by itself?
2 answers.
Give me some answers. Give me some answers. Don't. I'm not talking about this guy. I'm talking about this guy alone.
3
So
plus
give me
4.
some answers for this. Yeah, 3, 4. Is everybody cool with that? You guys
Yeah.
see how that answer works?
Yeah.
If X is 3 and Y is 4.
Oh.
5, 2. What else?
1, 6,
1, 6.
0, 7.
0, 7.
8, negative 1.
8, negative 1.
2, negative 9.
All right, let's. You're all like, if we just keep going, maybe we can just do this whole thing.
We get to those 18
You
billion
guys
answers.
get the idea. 1/2 and 6.5, blah, 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 right? You can go crazy, right?
We wanted to get to those 18 billion answers you wanted.
So, remember, why do we graph lines then? That's what we were doing before. Why do we graph lines? Because how long would this process take?
Too long.
So if I graph a line and connect it there, I've given you all the answers, right?
To infinity.
Now, which one of these answers? So if I were to graph this line, it would go through all these points, right?
Yeah.
If I were to graph this line, somebody give me some answers for this. What are some answers?
5 minus 2,
5 and
Minus
2.
4 minus 1.
5, 0,
7,
Minus 4.
4,
6 minus 3.
6, 3. How are we doing? Is that
1,006 minus?
1,006
Minus
and
1,003.
I like it. Now, right there, now thankfully, you're not going to have to do this every time, because if you have to solve these problems like this, can somebody see what the answer is to the whole system? What's the answer to the whole system?
5, 2.
Yeah, where do you see that?
Where they
Why is
are.
that the answer?
Because that's where they're in both.
Because that's where they're both true, right? That's the one that's the one point that solves both of them. So that's the idea behind the systems of equations. They each by themselves have an infinite number of answers, I'm hoping that together they have one answer, right? So let me give you an example. You can see this again here.
So you can't have infinity as an answer for those.
Now be careful, you could. So let me give you a couple examples. Let's say that, let's see, who wants to tell me how old they are? Whisper in my ear. Don't say it out loud. Tell me how old they are.
Yeah, I'm old.
Okay. All right, so if I were to tell you that Pat and my age, when you add us together, you get 91. Can you tell what either one of us is?
No.
Don't tell me if somebody heard her whisper. Don't
X
say it.
plus Y equals 91.
Okay, good, right? So this is a real life situation. We say, for example, we can only have so many men and women on an elevator, but by itself, it would be men plus women equals something or other, right? The weights or whatever. I need more information to see what the real answer is, right?
Men plus women.
So right now, I can't tell. I've got two things I don't know, one piece of information, right? So I said that Pat plus Jeff. No, I've forgotten what the hell I said. 91, thank you. So I need more information. So if I told you that
Jeff is,
Pat minus Jeff equals, now I forgot how old you are. Crap, hold on. Okay, now I get it.
Yeah.
You can do it, Jeff. 13. Couldn't you graph the lines and so forth, right?
Right.
Because now, how many things do I not know? 2, your age and my age.
Right.
But how many pieces of information did I get?
Two.
2. Right? How we doing? So does it make sense? I have to have as much information as what I don't know. So that's why you can make this into, this is not a mathematical idea really. If you're trying to solve a crime, aren't you trying to collect information because you have all these things you don't know?
Had to go backwards, right?
So you can never quite, maybe sometimes you don't quite get enough information, but you try to make the case and you try to say it all points in this direction. Can you say it for sure? Well, no, if I could, this whole thing would be easy. But I don't have as much information as the things I don't know. So that's why it's difficult. If you have as much information, it should be easy, right?
So in this case, you have to guess.
No.
No, in this case, I can tell the answer. You could, right now, the only method we have is for graphing, and I really don't want to graph that, but I just want to give you the idea, a physical representation of what we're talking about. Now, let me ask you this. If I said, I'm twice as old, and who do I look twice as old as? I'm twice as old as you, right? How old are you?
27.
All right, I'm not twice. You're back there waving your hand. Like, hey, look about these people. All right, so if I'm twice as old as somebody here, right? Let's see. How old are you?
18.
Okay, let's pretend. I remember when I was 36. So say I'm twice as old as you. So you don't know either of our ages, right? Pretend like you don't know either. I say I'm twice as old as you are. And you're like, okay, that's one piece of information. That's not enough. And I say, okay, well, she's half as old as I am. There you go.
Done.
What's wrong with that?
You just gave the same piece of information twice.
You guys with me? If I say I'm twice as old as she is, and you're like, I need more information, and I say, okay, she's half as old as I am. Did I just really tell you the same thing?
Yes.
So sometimes with these systems of equations, it'll be hidden, but when you work it out, you'll realize, well, they gave me the same piece of information twice. I get an infinite number of answers because they didn't give me enough information. You see what I'm saying? Okay. I'm getting a little ahead of myself. That's all right.
For some reason, I'm thinking that 13, I think, is given, when you wrote P minus J equals 13, for some reason, I think that's the difference in the numbers that adds up to 91 for some reason. Like you could have...
And actually, wait a minute. Now I remember it was 15. Yeah, 15. But anyway, yeah. So
Like that could be the difference in between the two numbers, so we can work
yes, right.
from there. 15. So
we're going to work to a point. I really don't want to graph these necessarily because their y-intercepts are kind of huge, right? And they're very far apart, right? So I don't want to list a bunch of possible answers because that could take a long time,
yeah.
right? But let's
Like
do a
the difference
couple
between the two ages is 15.
that we can graph. So the graphical method for solving systems. Okay. And so really what we did here is we basically graphed it without graphing it. I mean, we made a bunch of points, we just didn't put it down. But it's good to see the visual of what's going on. So say I have a system of equations, x plus 2y equals, let's see, I guess I gotta make it work now.
X plus 2y